In section 1.1, we're going to be looking at limits of functions. And so to get us to this concept of what we're going to do with limits, what I want to do is I want to start with an example and look at quite a few different table values. Now, this is only an introduction, so we are not going to be looking at 8 different table values every time we look at these limits or these equations, but I want you to kind of see what's happening as we look at it. When we're trying to look at limits, we're trying to look at an idea of what is something is approaching. And so we don't want to just define something at one point like you do in previous courses or previous concepts. We want to begin to kind of slowly get closer and closer to something and see what's happening at that point. So for this one, you can see that we're going to say consider f of x equal to x cubed minus 1 over x minus 1, where x does not equal 1. And we know that if we were to plug in 1 into our denominator of this function, we would get 1 minus 1, which is 0. And so we know that at 1, this function is undefined because we can't ever divide by 1. But I want to know what is going on with this function as it gets closer and closer and closer to 1, because I know 1 causes division by 0, but all the other numbers are not going to cause division by 0. And so I'm going to grab my scientific calculator off to the side, and I know you can too, and I'm just going to plug in values. Now remember, when you're plugging in values, always put parentheses around anything you're plugging in for x, especially when you're cubing it. And don't do it all in one swoop, because you want to make sure your entire numerator is being divided by your entire denominator. So always kind of do your numerator plugged in, enter, divided by your denominator. And so what I want to do is I want to look at these values, and I just want to see what is going on as we get closer and closer to 1, and what kind of predictions or assumptions could we make. So what I do is I just pick a value. I'm going to pick 0.75. And so I'm going to take this 0.75 and I'm going to plug it into my function over here for x. And I'm going to see about where is that approximation. Okay, well, if I plug in about 0.75, then just plug in my calculator, and I'm going to round just so we can kind of see an idea here. I get 3.13. I go, you know what? Well, here is the value of 1. And knowing that at 0.75, it's at about 2.333, gives me an idea that we're right here on our function. And then I'm going to go to 0.9. I'm going to plug 0.9 into my equation, and plugging it all in for x, again, parentheses appropriate, etc., you get 2.71. Okay, so when I get a little bit closer, so now I'm at 2.71, excuse me. And then when I go to 0.99, this gives me a value of 2.9701. Okay, so we're still a value of 2-ish, but we're getting closer and closer to, it looks almost like 3. So let's approach it from the other direction, and let's see what's going on when we're bigger than 1. I'm going to start further out. So 1.25. Again, I'm just going to write down these numbers for you, but you can get these just from plugging them in your calculator. It gives me 3.81. So I get a little bit closer. This gives me 3.31. Okay, now I'm a 10th away. Let's go a 100th away. Well, that gives me 3.0301. I'm going to get really close this time, 1.001. So I'm 1,000th away. So this gives me 3.003. So looking at all this information together, we can see that when we're coming from the left of 1, values that are smaller, looks like we're approaching 3. When we're coming from the right of 1, okay, 3.8, that's closer to 4. But as we get closer and closer and closer, and even this 0.001 away, we can see coming from this direction or from the right of 1 that I'm getting closer and closer. And so now, you know what, I can make an assumption here, and I could say, at 1, although when evaluated and plugged directly in, I'm going to, it looks like it's getting closer and closer to 3. Now, graphically, what's going on with this, looking at larger values or moving things around, this actually looks like, draw you a little graph here. This actually looks like this. Now I'm just rough sketching. And it actually looks like a parabola, which makes sense because I have a cubic divided by a linear, so that would reduce it down to a squared. And it has basically just an open dot at that value. And so what's interesting is, looking at the graph, we could definitely see it, and this is a really rough looking graph. But looking at the graph, we can see that it is approaching and getting closer and closer to 3. If we were moving from this direction up to it, we say, it's almost a 3. If we were moving from this direction, we're like, okay, we're almost at 3. And looking at the values, we can see that. And this is the general idea when we're looking at limits. We want to look at a value and see it. What is it approaching? What does it look like it's going to get to? And so you kind of have to wrap your mind around the fact that limits is approaching, not necessarily what's it evaluated at. So we're going to pick up notation, and for calculus, notation is a very important aspect of it. I am a stickler for notation, and when doing your, the only scratch work that I'm going to look at for you is your exams. And so when I'm looking at your exams, you need to make sure that your notation is spot on. It should look exactly like we do here in the notes. Any notation errors will be an automatic -1. So make sure, and that comes off the top of the grade. And I'm not just being difficult. This is an all-around calculus teacher thing to do. So make sure that you're always very particular with your notation. Notation in calculus is almost like leaving off an addition sign. It's almost like leaving off a multiplication sign or leaving off a cubed. It tells you the operation or the path that you're going to take to get that. So without the notation, we're not even in the correct concept or operation. And so what we want to do is, here is going to be our limit notation. I'm just going to kind of rough sketch a graph over here to the side. And it's just kind of similar to what you just saw before. And so at this value here, we call this C, and this is our X value. And then at this value here, we're going to call this capital L, and this is our Y value, or f of x, which is, your formal notation. And here's how this is going to read. The limit, and so let's write this underneath here. The limit of f of x as x approaches C is L. And let me correct this notation here. Okay, so it says the limit, and we're reading out this notation here. The limit of f of x as x approaches C, so you can see we kind of read that top to bottom on the left-hand side of the equals, is L, and L is always going to refer to that Y value that you're looking at. And notice we are talking about what is it as it approaches C, So you have to think about the path that it's traveling. What is it going to be as it gets closer and closer? You can see that's important, knowing that it's approaching, because in the previous example, there was no value at that number. You can just plug it in and move on with your life. You have to look at it. And you can also see in this previous approach, when we were right here at 3.813, we were like 0.25 away. It's closer to 4, which is not even the value it looked like it was approaching. So you have to get closer and closer and approach. And this concept is going to help us as we move into chapter 2. So that's why all of chapter 1 is going to be focused on this limit. It's not a long chapter, so you're going to have a test coming up soon. So now that we kind of had talked about what is a limit, we're looking at what is it approaching. We picked up this new notation here of figuring out the limit of x approaches C. Let's do some more examples, and I'm going to try and hit on the high points. I'm going to look at all these different situations that you're going to encounter. And so looking at this next example here, it says find the limit as x approaches 0, and I'm reading right here. Find the limit as x approaches 0 of, and then here's your f of x, or your function that is given. And so that would read, the limit as x approaches 0 of x over the square root of x plus 1 minus 1. And so again, we're kind of dabbling in this. And so, we've looked at the graph and the table. On this one, again, we're going to do a table, just kind of showing you how things are working out. We got to start slow, and then we'll jump into some shortcuts along the way. And so I'm going to approach this problem just like we did the previous one. We're going to start far from the left of it, and we're going to get closer and closer. You can see the values I'm starting with here are a tenth, and then I'm going to go to a hundredth, a thousandth, a 10,000th away, really close to what's going on. And we're going to figure it out from there. Now, if I straight plugged in 0, you can see it would not work. 0 plus 1 would give me 1. The square root of 1 is 1 minus 1. Lots of 1s there, but you still get undefined at 0. So that's a problem. We've got to take the slow approach here. If you plug in negative 0.1, and again, when we're plugging in negative 0.1, I'm plugging it in here and here and being very conscious of my parentheses. I'm using my scientific calculator. That's the only one that's going to be allowed in exam purpose. So get used to, the buttons from there. I'm going to plug in negative 0.1. That gives me 1.95. Go ahead and practice plugging that in. Pause the video. Practice plugging in. Make sure you're getting that same value, because if you're not, that's a problem. And then start the video back up again. Then I'm going to plug in negative 0.01, and that gives me 1.994. I'm going to plug in negative 0.001. I'm getting closer and closer. So that would be 1.9950. I'm going to plug in negative 0.0001, and that gives me 1.999995. Really close. And when I'm coming from this direction, we're already starting to see a pattern of what's happening with this. And obviously for multiple problems, testing situations, long-term goals, plugging in 9 values is not going to be beneficial and time efficient. But I want you to see what's happening here and very much see the details as we move forward. So I'm going to go on the other side of it, equal distance apart, look at 0.1, and that gives me 2.05. I'm going to plug in 0.01. 2.00499. And again, plug these in your own calculator. Make sure you're seeing it here with these values. And then 0.001, that's 2.0050. Up, left off with 0. 3 zeros, 50. Then really close, I'm at 2.0005. And so you can see as we're getting closer and closer from the right, again, you see that pattern emerging, and we're looking to be at the value of 2. Now again, how does this look? How am I going to write this out? This is going to be the limit as x approaches 0 of x over the square root of x plus 1 minus 1 would be equal to 2. Once you take that limit, you remove that limit notation. And you can see what I would do is if I was writing on lined paper is I would use 2 lines to write that out. You want to do limit as a lowercase l because when we do it as an equal to, notationally, that's a capital L like you saw in the previous definition. And again, let's emphasize here that your limits, and typically you're going to see me write a limit with a capital L that's cursive so I don't accidentally think it's a 1. Limits are always y values. I can't stress that enough. As we move forward, start looking at other things, I don't want you to get confused. So just remember that part right there, beneficial. Limits are always y values. So let me stop and let me show you something here. Look at this graph here, and I want it to work with this illustration that we kind of move things around to kind of help you to understand where different things are. So for this one, the value that we want to approach is 3. And so, 2. So your x is 2, you can see that here. And we want to let x approach that value. So that's our blue line right here. And we can see that visually it's at 3, but what I want you to do is I want you to watch this value here. See this red value? Notice that as I move x closer and closer, and I'm really far away, you can see that that red value is changing. Oh, it's changing quickly. We're getting closer and closer and closer, and just like what we did with our function in the table, you can see as we're getting closer. Okay, look, we're at 2.44, and we're watching this value here. Our C value is 2, so look, I'm at 1.44. As 1.44 is getting closer and closer to 2 in blue, closer and closer, what value are we approaching? You can see we're at 2.4. Get a little bit closer, 2.62. Look, it's moving closer and closer, so you can see 2.8. I'm looking over here. Closer and closer. Look, I'm at 1.86. And it's at 2.86. We can make some predictions here, closer, and then we're at 3. And so you can see I'm approaching it from this left side. It's getting closer and closer and closer. Look, I'm almost there. You can see we can make an assumption and go, okay, it's at 3. Now it also works from the right-hand side. I'm going to move down here. So you can see as this red dot is moving along this line, and it's going to jump. This is a piecewise function, so it's going to jump. So moving closer and closer. Move my green dot here. Closer and closer to that value of 3. Notice that it's making an assumption. It's moving up. And now this one is not a very good example because you see the assumption that we're making is that it's going to be way down here as we get closer and closer and closer. So we're going to talk about what this comes to next, and we're going to talk about these values. We'll probably jump back to this example as well. But I wanted you to understand that when this X, this green, we're moving closer and closer to this blue value, what is happening to our red value as it's getting closer? We're able to make this assumption over here. Now we're going to come back to this example. It has 2 more things that we can take value from in order for our conversation. So let's jump back to the notes and look at another function. We're going to just do quite a few examples in this lecture. So let's go to this next one here, and it says find the limit of f of x as x approaches 2. So here's what it's asking. We're going to write it out notationally. They have it all in the sentence here. And so we're going to say, what is the limit as x approaches 2 of our function? Or more specifically, what is the limit as x approaches 2 of this function f of x? And notice with this limit of this function, I'm going to go to that step next. Notice with the limit of this function, it's a piecewise function. So it says f of x is equal to 1 when x does not equal 2, and f of x is equal to 0 when x equals 2. Now remember, if you remember from piecewise function, these are known as your conditions. And so you first look at your conditions on the right, and based on wherever you are with your x, dictates what y value you're going to use over here for those x values. And so in this case, remember, just a number is a horizontal line. If you just had y equals 2, it would be a horizontal line at 2. For in this case, y equals 1, it's a horizontal line. Y equals 0, horizontal line. So don't let this throw you that there's not variables listed there. And so what I want to do is let's just pictorially look this out. If you have something that's kind of confusing like this, but it's so basic, that's what kind of throws us. 1, 0, not much written. What do I do with it? Let's just kind of rough sketch it out here. So this is saying when x is 2, x is equal to 2, it's going to be at 0. So I'm going to put that dot here. And so I've got this part fulfilled. When x is not 2, so everywhere else, it's going to be at 1. And so this is going to be a horizontal line at 1. When it gets to 2, it's going to have an open circle there because it's not equal to it there. It's going to continue out. So let's take our concepts, our ideas, and it says, what is the limit of f of x, I'm going to erase some of this, as x approaches 2, approaches 2. So look at your graph. If you're coming from the left-hand side, it looks like it's approaching 1. Remember y values. If it's coming from the right, it looks like it's approaching 1. So if we are looking at where is it approaching, then we would say the limit of this function would be equal to 1. Although f of 2 is equal to 0, we are looking at where it is approaching, and so that's how we get that value of 1. It can be difficult to wrap your mind around this, but I just want to encourage you to get with the approaching. If you're getting that notation and the lingo of how we read it, that is what's going to benefit us and help us with this.